Hello, everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar is part two of the power of mill-turn in SolidCAM 2016. And again, will be given by Florine Eugene, who is our post-process manager for mill-turn, as well as a leading expert in the mill-turn when it comes to mill-turn. So without any further ado, Florine will make you the presenter, and you can unmute yourself and go ahead.
Thank you, Sydney. Good morning or good afternoon. I will share my screen and start the webinar. For today, what I plan to present you is and to show you is how to work in 2016 version with multiple coordinate system. We call it Multimac. It's an additional option near the option that you have before to work with positions. You create one coordinate system and positions. So we have the option to use multiple coordinate system on each face and how to handle this in the setup, how to mount the part on the machine. Another point is how we have a 6-axis machine, a mill-turn 6-axis machine, how to handle this machine, how to work with different combinations on 5 axes. And the next point should be moving parts from one machine to another, changing the machine on one programmed part. It was a very difficult step in the previous versions, because if the kinematic is different, you need to edit and recreate the coordinate system, and some geometries you need to define again. Levels, all the operation, you should be involved almost in every operation and to fix the part to work on another machine. So I will show you today another way to move the part from one machine to another, which is more simple in 2016. I start with a simple part. You already know this part from our examples from the install. And I choose a 3-axis machine with a 4th axis mounted on the table. I have only a few simple jobs here, operations to remove the material on this face, and on the opposite side we have this small slot here on a different angle on position 3, and drill here on this face and drill around 4 axis here. Now on the tool table you already see the tool table with the new mounting. In the previous webinar we can see the machine. We already talked about this. And here we define 3 tools, the face, milling, and end mill, and the drill. Let's go and see the machine in the setup also. I can see the part mounted on the 4th axis. And what's important here to know is to work on this machine, 3-axis machine, 4th axis, I will define the home with Z-axis up, and the part will rotate around the X-axis. I'm going to take this part to another machine, to a 5-axis machine. The mounting will be different. The coordinate system will not match for this part. So let's start to simulate just a few operations to example what we want to show, to demonstrate. So the part mounted on the fourth axis, and we have on first angle A0, A180 in operation. Now this small slot, A minus 150, and drills, and drill around 4 axis. Just an example. Now let's take this part and move to another machine, to a 5-axis machine. I will save the part, save as. Let's call it, already saved a few times, _3 demo 1. And here we will change the machine to has UMC 750. It's a 5-axis machine. Continue. Calculate. For now, everything is okay. I don't have anything wrong in operations. There is no red dot points alarming that something is wrong. Everything is okay. But if I'm going to I'm tool table, here is the machine. We show only the moving devices in this preview. You can see the entire machine in machine simulation. And here we have the spindle and the 5-axis device tilting and the rotating table. Now, if I'm looking in setup, I'm going to see in setup, this is how the part is mounted with the previous, from the previous machine, previous kinematic. But today I want the part to be in the center of the table and rotating around this new axis. So what we are going to do to solve the problem, that's very simple. I will not edit nothing. I will not change nothing. I will add one coordinate system, add a new coordinate system, 3 for example, in center of revolution in the same location. That's important. It should be in the same location as previous center of revolution, but now my z-axis is pointing up. The part will be rotated around z-axis. Okay, so the coordinate system, the new coordinate system is defined. In the setup, I will use this coordinate system to position the part on the machine. Mach 3, position 1, on the table, and the shift is different now. I have 0 in X and Y, 150 in Z direction. I'm looking again in the setup. Now that's the part mounted correct for the new machine. All that I do is creating a new coordinate system, but I will continue to work. And this new coordinate system just helps me to mount the part in the correct orientation. I will continue to work with previous program. Nothing changed here. Let's see the simulation. That's a big step in moving parts. A lot of customers have request to do much easier convert the program from one kinematic to another. This is the entire machine. It's a 5-axis UMC as. I will hide machine. And the same program will run as previous, working on 4th axis. First operation and the second, slot and drills. No difference. So I think you already agree with me that converting and moving parts from one machine to another is much more simple today. Now let's go to the next example. and open demo number 2. Okay. Also a part that you know from installed from our examples, and here I'm going to show you a 6-axis machine. We have X, Y, and Z, and we have 2 axes on the head, on the spindle, a tilting and rotational axis. We have additional axis, rotary axis on the table. This table also have a rotation, so we have a total of 6 axes. A, C on the head, B on the table, 3 rotational axes. In the setup, I use Mach 1 position 1 coordinate system to position the part on the table, and shift X, Y, and 540 millimeters from the table is my coordinate system. If I'm looking, that's how the part is mounted. I see here the stock and the machine. Now we'll see the machine in machine simulation. Okay. First, what I do is a turning, the simple long turning finish job, just to demonstrate the the capabilities of this machine. It's a milling machine with turning option. And also on this machine, because we have 3 rotary axes, but in a operation we can use only 5, 3 linear and 2 rotary axes. One rotary axis will always remain not used. We call it it's a non-kinematic axis. The axes that are used in the operation are kinematic. The 6th axis is not kinematic axis. So this not kinematic axis, we need to control it with machine control operation. Here I define a turning operation, and we have in geometry the possibility to select only turning when I select a turning operation, but in milling I have the possibility to select what kind of combination of axes I want to use. A and C, that's a head-head kinematic, or A and B, one axis on spindle, one axis on table, A and B. That's a head-table kinematic. Both options works, and we just need to select them, depend on part position on the table, the angle of a tool, and the limits, machine limits, range. In the first operation, milling operation, I just have a drill here on this face, and I also have a drill on this face, but I use different kinematics. For the first drill, I use A and C at the head option, and for the second drill, I will use A and B head table option. Now, first I want to suppress the MCO here and to show you what can happen on this type of kinematic. I will select only the first 2 operations, simulate, so this is the entire machine, Unispeed 5T 6-axis machine with turning mill turn, with a milling machine with turning capabilities. Let's hide, and I use a standard 45 degrees holder with turning tool, creating only a finish toolpath to demonstrate you how it's working. Now, next operation is drilling. I want to drill here on this face. This is how the tool will approach the part, because I'm using two rotary axes on the head and head kinematic. The table will not move. The table is on reference, B on 0 degrees. So this is the angle. It's the only possible approach, but is not good for us. Create a collision, maybe limits, alarm we will have. So what we can do in this case, I will rotate the B-axis, for example, minus 90 degrees. Now, minus 90 degrees, I will bring this face here. It will be a lot of easier for the machine to reach the position. So that's what I did here in the machine control. I bring the B-axis because it's 6-axis. B-axis is not kinematic, not used in the operation. I control it with the machine control operation, bring it to minus 100 degrees, and unsuppress. Let's simulate again. And see the difference. First operation. Now machine control will rotate the table minus 100 degrees. The face of the part that we want to drill on it is here. And that's the new position, new calculated position. Depend on location of the part. Now we always take in account what is last position of this new non-kinematic axis, the B is here. So the next job is calculated accordingly to our angle. I can change it to another position and we will get a different head-head angles combination. Now the same operation I want to do it with kinematic head table with axis A on the head, on the spindle, and axis B on the table. But before I will do this, now if I'm using A and B, C axis is not kinematic. So in this machine control I will reset and C axis, bring the C axis to home reference, to 0 position. And let's continue with the simulation. Okay, we'll jump. Turning MCO rotation minus 100 degrees. This is the first operation with head kinematic. And now I will reset the C-axis to 0. This is the C-axis. Now will not be used in the next operation. And now only axis A on the head and axis B on the table will be rotated in order to get our tool perpendicular to this surface. So both options can be used, depend on the position of the part on the table, axis range limits, and user preference. Sometimes several options can be correct and can work also. User preference is also taken into account here. That's how we work on this machine with C-axis. That's our possibilities. Next operation. For the next operation, I use a new setup. We don't have two tables on this machine to transfer the part from one table to another. So we use a new setup here, and we position the part again, reversed, in order to work on the opposite side. So I create only a turning operation just to demonstrate after setup how it's working. I also use a different angle on B and a different approach. So that's how we work on a 6-axis machine. Now let's try to take this part from this vertical mill turn machine to a horizontal mill turn machine. I have an Okuma the Multus U3000, a new machine in our collection. So again, let's save the part. And I have 1, 2, again it's 3. And on this part we will change the machine to Multus U3000. Now, when we're moving in a mill turn from one kinematic to other kinematic, we have different submachines. So we have operations created on the previous machines with submachine turning, milling A and B, milling A and C. Now, on the new machine, we also have choice with which submachine I want to work now. I select upper turret main spindle for now, for all of them, and the program is converted. Again, I just need to calculate maybe all, but everything is okay. The operations, geometries, coordinate system, nothing wrong here. MCO. I don't need this MCO because on this machine, on the new machine, I don't have the sixth axis to control. So I can suppress or I can delete whatever I want to do. For now I will suppress these operations, MCO. Another thing that I want to do, on this machine I have 2 tables, so I don't need to use a new setup and to rotate the part on the same table. I can move the part to the other table. So I will delete the setup, and in the operation I will select this operation. I will work with back spindle, upper turret on back spindle. Save and calculate. Now I get a message. The stock is absent on selected submachine table. Of course it's absent. I didn't move the stock, so the part, I create an operation, but the part is not transferred to the back spindle. So before the last operation, after the last operation on previous table, in the setup, for back spindle, I will use Mach 2 position 1. That's the coordinate system that I use here for the job. And the shift now is the same as the length of this part, just to pull it out of the spindle. Now, after this operation, I will use the MCO, CNC operator. I will move the part manually. In the previous webinar, you already see that all the cycle that we can do, part transfer, move the back spindle, catch the part, clamp, unclamp, move the part, and all this cycle. Another option is to use manual stock transfer. The user will take manually the part and move it to the other spindle. So that's also an option. Move it where? To the back spindle. Now the last operation is correct. Have a stock. We don't have this red dot that tell us that something wrong in the operation. Now I will calculate all, and let's try to simulate. Okay, this is an entire machine, the new machine, Multus U3000. And you already see the part is mounted. It's bigger for this machine, but that's and for the previous machine the part was okay. We have a big table there, and we start with turning and milling. But what's happened here? The angle pair are different from one machine to another. In one machine we prefer to use first angle pair, in the other machine we prefer to use second angle pair. That can be different. So we are going back to the operation, and in motion control we say on this machine I want to use first angle pair. We always will get two options. Okay, already calculated. Now let's check also the next operation. First angle pair, okay. Simulate again. We jump on the turning, and now the drilling operation is in the correct position, the machine limits, and the second, and the part is moved by a operator to the back spindle. Last operation of turning, and that's all. This is how we move parts from one machine to another today. Nothing, it's very easy. We don't change anything in the coordinate system, in the operation, in geometries. Everything is converted correct. We just use another coordinate system if we need. Here we don't need. The coordinate system is matched to the main spindle and to the back spindle. Let's see the third example, and here I will use the same, the previous machine milling vertical mill turn machine, to see how we work with multiple coordinate system, Multimac. And this option is used by castings manufacturers who want to work on castings, and on the drawings you have a lot of datum points. So you have a datum point on this face, and you have here another datum point. That's mean the center of this feature should be, the drills are related to center of this feature, and here again the drills are related to center of this feature. So you always need to create a coordinate system on each face. Of course you can work with positions, there is no difference. We work in the past with position, you can work today with position. But the change is only you can work with also with a new coordinate system, a new Mac. So for this part I create 3 coordinate system. I have one here, the second is here on this face, and here we have a third coordinate system. For the setup I use Mach 1 position 1 to mount the part on the table, raise the part 800 millimeters from the table. The tool table, I have 3 tools defined here, the same machine that you already see, and I have a internal turning tool with STL holder, and the face milling, and the drill. In setup, as I already told you, we use I click. Okay, it got stuck. I wait. Okay. So the part is mounted and raised 800 millimeters. I didn't define the feature, but you know that the part should be positioned and catched on the table with a fixture. Now, operations. I create a turning operation where I remove the material inside the cylinder on this step and here on the face with one geometry. We can see the target and we can see here also the stock as translucent part. After turning operation, using ANC head-head kinematic, I create on Mach 2 position 1 on this face, the face operation, spiral, and the contour to remove the material on the first step up to here, and a drill operation. Now the same operations I will do again on this face with Mach 2 position 1, but with different kinematic with A and B. After that we are going to opposite side of the part, doing the same, a face, a contour and a drill with AC kinematic and with AB kinematic, head and head table. I will simulate this. Now, many users ask me if we recommend to install Windows 10 or not, what the opinion. So from our side, we already tested Windows 10 with SolidWorks 2016 and SolidCAM. You can use 2014, 15, 16. There is no difference. It's working. Who want to work and to install to update Windows 10? Make sure that you can update SolidWorks to 2016. That's our recommendation. Now we already have the part, and for turning operation this is our stock. Spinning part create this form, this revolved form, and it helps us to detect collisions. Going down and turning, removing all the material, we clean the material on the face and the internal side. Now, after a turning operation, when we clamp this, the table to work on milling, the table is going automatically to 0, to reference. So the table is on 0 degrees. In order to reach this position, this face, the head-head kinematic will have a A0 position, C 90 degrees. Spiral, a contour, and drills. Those are the movements. Now I want to do the same but with axis A and B. Rotate the table. Before that, axis C, which we already talk about, this is a not kinematic axis, not used in the next operation. I will send this axis to 0. Send the turret spindle up, C axis to 0, And now this is how the machine will approach the part. It will axis A and axis B on the table. The same operations and the contour and the drill. Now sometimes you will have problems with limits in Z. Sometimes you have problems with limits in Y-axis. Depend on how bigger is your part and where exactly the position on the table, you can select one of those two options, two different kinematics. Again, I will raise up the spindle and bring the table to 0. Now I'm going to work again on Mach 3 position 1 on the opposite side of the part, but with kinematic AC head-head. So B-axis I'm handling, sending to the 0. And work from the opposite side. Many options, but everything is in your control. You can select what is the best for you. Again, I will raise up the turret and resetting, sending to the home reference axis C, and using now again A and B kinematic. The single difference between this operation and this operation is now the B axis is on 90 degrees. Before we have B on minus 90 degrees for the opposite side. But I use the same operations. So that's how we handle today the 6-axis machines, and this is how we move parts. We convert parts from one machine to another using the setup, creating a new coordinate system maybe, but all your program will be preserved and nothing to edit, nothing to change there. Those are the issues, the subjects that I want to show you today. We'll continue in our future Milton webinars with many interesting things. I want to talk, there are so many. I want to talk about synchronization. It's a very important point, but it's a webinar, I think, more than an hour long, and it's programmed for our future Milton webinars, and more and more tips and tricks. But for today, that's it. I'm looking at the questions, and I don't see any questions. If you have any question, you can say, write the question and I will answer to you. If not, I thank you and see you next webinars.
Okay, thank you very much, Florian. And again, if you have any more questions, you can always write your questions even after the webinar to webinar@solidcam.com, and the questions will be answered from there as well. All right, Florian, thank you again very much, and we'll see everyone again at our next webinar. Take care and have a great weekend.
Thank you. Bye-bye.